Hello, hi everyone. Can you hear me? Let me know if everything is fine. Okay. So once you just confirm, I will just start. Okay. Audio is fine. Great. So let's just get started. Before I start, if you like to tell me that how was your experience with this test, then just let me know. It will be great that you tell me that how was your experience, and then we will be starting. Okay. Great. So let's just get started, right? Okay. So basically, here we will be discussing the remaining questions. So few of the questions, I think half of the question Deepak has discussed, and now the remaining half of the question I will be discussing. Okay. So let's just get started. So let's just start with this very first question, which was asked there in test. So this question was related to C programming. Okay. So in this question, I aim to ask regarding hash define, right? So which is basically macros. So what this question is saying, that suppose there is a valid C program that contains tree equal to trunk. Okay. Now which of the following is true? Now here in this question they are saying that tree and trunk both must be hash defined. Okay, both must be hash defined. This is one of the option in the question, and if you go to the next option is saying that tree must be hash defined, but trunk doesn't have to be hash defined. So basically, in this particular question, see here that you are using tree on the left and trunk on the right. So obviously, trunk doesn't have to be hash defined, right? I mean, if you want, you can define trunk, but it doesn't have to be hash defined. But 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 can the tree be hash defined? This is the main question, okay? Because you are using this on the left. See, if you are writing, let's suppose hash define trunk, okay, 5, then it is very much legal that to have basically, I mean, instead of trunk, you will be replacing with the 5. So it is very much legal for the trunk that you can definitely use trunk on the right hand side. And but it can be or cannot be, I mean, it could be hash defined, or it could be just like this. Okay, it could be just like this, int trunk. It doesn't need to be hash defined also. It int trunk equal to 5. Okay, int trunk equal to 5. So both are okay for the trunk. I mean, it may be hash defined, okay, or may not be, right? For trunk, both are okay, may not be. Is this fine to everyone? For trunk, both are okay. Now, what about tree? What about tree? Now we are using tree on the left. So let's suppose I define tree like this, okay? Hash define, tree, tree. And then if I say 5, so can I use 5 on the left? 5 equal to trunk? Obviously no, right? So see here, now basically I like with respect to trunk, I hope things are okay, right? But with respect to tree, if you see, if I define like this, hash define tree 5, then obviously I cannot use 5 equal to anything, right? Because this is a constant. Generally we use constant, I mean the hash define for the constants only, but it turns out to be that we can use hash define for the variables also. Okay, although we don't use, but suppose we say, okay, suppose we say that hash define tree a. Okay, suppose we say something like this. This is also legal. Okay, this is also legal in the sense that if I use, let's suppose there's a main function. Okay, in the main function, let's suppose there is some variable int a, and then I say instead of a equal to 5, I say let's suppose a or a equal to 100, or whatever. Instead of that, okay, this is also fine. Instead of that, if I say tree equal to 100, okay, tree equal to 100, tree is nothing but a, right? Tree is nothing but a. Okay, so see, if I define this hash define tree as a variable, okay, if this is a variable name, then I even can use on the left. So basically, in this case, tree can also or cannot be, okay, in hash define. For example, if I use on the left, if I want to use tree on the left, okay, tree on the left, then I can hash define tree as a variable also. Or maybe, okay, or maybe I can use so basically what I'm saying, that if you're using a variable here, then you can use tree as a left. Both can be, I mean, tree can be also hash defined. This is my point. See, regarding the trunk, see, I'm using trunk on the right hand side, right? For example, I'm using tree equal to trunk, right? So I can hash define this trunk like this, hash define trunk 5, right? Or maybe I can directly say int trunk equal to 5, right? So I can hash define trunk, okay? Or may not be, I can I mean, it need not to be, it is not the case that it must be hash define, okay? It is not the case. Similarly for the tree, okay? So if I'm writing something like this, okay, tree equal to trunk. Similarly for the tree, that if you are using tree on the left, then you can hash define this also, okay? For example, hash define tree and then a variable name, and then you can say, instead of writing, let's suppose later on a, you can either write a or you can write tree. So both can be, okay? This can be and this tree also can be, right? So both can be hash defined. But in the options they are saying both must be. No, both not must be, right? It need not to be the case that both must be, as we have seen, right? I mean, trunk may not be, and similarly trunk tree may not be, right? A tree can be just a normal variable into tree, okay, into tree. So both must be, no. Must be hash defined, a tree must be, no. Both actually can be, right? So so whenever there is a must be, then this option is wrong. Tree cannot be, no, it can be actually. So actually in this particular question, this should be marks to all, because I intend to ask something else, and it happened to ask something else. So basically it will be marks to all, this particular question. But if I just change the option, okay, if I just change the option, so one of the student actually commented the same thing, and I really appreciate this comment. But if I just change the option, and if I just say that tree and trunk both can be hash defined, then in that case C is the correct answer, okay? So with this change option, C is the correct answer. Both can be hash defined. Is this okay to everyone? Let me know if that is fine, okay? So both can be hash defined. It is not the case that both must be. Understood? Okay. Now let's move to the next question. Okay, this question was easy one. What this question is saying, that void swap and print. There was a function. Now they are having two list or two array. Okay, and then they are saying that if list of I. So for example, first list is first 537. Second one is 483. Okay, if this number is greater, if this number list of I means list one of I. So basically this is list one. This is list two, right? If list one number is greater, in that case you swap. Okay, if this is greater, then you swap, right? Then you have to swap. So you will be swapping here. So it will be 4 and it will be 5. So okay, I hope you got it. After swap, it will be 4 and it will be 5, right? And then this is 3 8. So in that case, it will not be swapped. And this case, this will be swapped. This is 3, this is 7, right? Now what they are saying, just add their 0, this first index, this is first index, and this is the second index. So if you add it, then what will the answer? Let me know. So this question was easy, right? So were you able to solve this question in exam? You just have to swap and just have to check that what is the answer. Okay, but here if you notice that we are not just swapping it one time. I think this is 0 to 3. We are swapping, and then list 2. Okay, list 2 of 1. Okay, we are just adding. We are swapping it only for the one loop, but the adding is basically not this 3. So list 2 of 1 and list 2 of 2. So I think this is 8 plus 7. Okay, this is not 3 plus 7. 8 plus 7 will be the answer. So 15 is answer here. Understood? That was, I think, easy question only. Yeah, silly mistakes can happen in easy questions also, but yes, there was easy question only. Okay. Now let's move to the next question. Let's see this question. So in this question, what they are saying, what is x2? Okay, I think there is one bracket that is missing. So this bracket, right? Okay. So I think in the original exam, the bracket was fine, most probably. So let me just quickly check. On the gate, if I'm taking the screenshot from gate or flow, then the bracket got missed. Okay, no problem. So this is the bracket, right? In the original exam, bracket was fine. Okay, so in the original exam, let me just take the screenshot what I put in the original exam. Okay, I will just edit this on the gate or flow also. So basically, this is a bracket here. Okay, this is a bracket here, right? This is a bracket here. Don't worry about this option E, it is just extra option. So now about what they are saying, if you're writing x2 plus 4, right, and then 3, then what will be the equivalent expression? So this x2 is nothing but x plus 2 whole star, x plus 2 star, right? And then you are having plus 4, right? And then this is 3. Then it means if you are using 3 here, it means basically star x plus 2 plus 4 plus 3 and then whole star. So this whole star here, then this 4 and 3 will get added, so it will be 7. So what will the answer? This will be x plus 2 star and then plus 7 whole star, right? So B is correct answer here. Is this fine to everyone? Let me know. Okay, great. Now let's just see this. A bit stuffing based framing protocol uses 8-bit delimiter pattern. So they are saying that this is a 8-bit delimiter pattern, right? So this is a flag that they are using. So 0, and then there are 1, 2, 3, 4, 5, 6, right? So 6 ones. 1, 2, 3, 4, 5, 6. Okay, and then 1, 0. So total these are the 8 bits. 8-bit flag. So basically this question was already asked, the similar question was already asked in GATE. So if you notice, there was one question in GATE 2000, let me just tell you, 14, right? Yeah, GATE 2014. Okay. So let me also put the screenshot of that particular question. So this particular question has been asked. Although I have taken this question from some standard university, but I have used this particular line. Okay, same as GATE 2014. I have copied this particular line. I have changed. They have written flag and all, but instead of writing flag, I have written delimiter. Okay, because I just wanted to match this question language. Okay. Now what this question is saying: if the receiver receive these bits, right? Then what should it do? So basically, if you notice, this is 0, and then there are like 3, 1, 4, 5 ones, right? These are the 5 ones, and then 0. Okay. So received code word is basically something like this: 0. Then there are 5 ones, 1, 2, 3, 4, 5, and then there's a 0, and then there's a x, and then there is 0, right? Now, if this is your flag, okay, then what does this mean? It means, we have already seen in computer networking lectures, it means that you will be appending a 0. If this kind of things are already appearing in the data, so if this is your flag, then there's an obvious rule that you will be appending a 0 after 0 and then 5 ones. Okay, after 0 and 5 ones, you will be anyway appending a 0. So this 0 is appended. Okay, it doesn't matter that what is next. It doesn't matter what is next. The rule is that if you have 0 and then 5 ones, then this is appended. Okay, irrespective that what is the future bits. Okay, irrespective of that, this is definitely appended. Okay, so this 0 will be removed irrespective of what is the future bits. So basically, remove the 0 before x regardless of x. Is this fine? So we will be removing the 0. Okay, regardless of the x. Great. Now let's just move to the next question. Okay, this was an interesting question, I think, right? So in this question, what they are saying, consider the following function, and this is the function that they have given, that takes a node of a binary tree as an argument and tries to find something. Okay, so it is finding something. Let's just see that what it is trying to find. So let me just copy this on the next page, and let me just show you that what it is trying to find. Right? So what are the options here? Let me also copy the options. Okay. So these are the options that I have. Now, what was your answer for this question? So let's just see that what they are saying. Let me do one thing. Let me have a tree. Maybe I can have this tree. Okay. Let me draw this tree by itself here on the same page, and then I will be just executing. Let's just have some tree, and then I will be executing this code and on that tree. Okay. So suppose that I have some tree which is something like this. Suppose this is 1, then this is 2, this is 3, then there is a 4, and then 4, 5, and then there is a 6, right? Suppose this is a tree. Now let's just try to execute this code. What they are saying, if p equal null, then return -1. So currently, let's suppose I'm running from the start. Okay, currently it is not null. So okay, then what should I do? If p left null, then do something like 1 plus find something, right? If p right null, then do this. Otherwise, go to this. Else 1 plus minimum of whatever is the find of left and whatever is the find of right. So I will find out minimum of 1 plus minimum of this and this. Okay, so 1 plus. So here I've taken the longer tree, but I will be finding whatever this is returning, right? Minimum of this and this, basically minimum of these two, right? Minimum of these two. Okay. So let's just do one thing. Let's just see that what it is doing for this, because it seems like minimum will be for 3 only, right? Minimum will be for 3 only, because it is doing 1 plus 1 plus always. So minimum, most probably whatever this is returning. Let's suppose this is returning, I don't know, but let's suppose this is returning 5. Then most probably it will be returning 2, 3, something like this. So minimum will dominate, right? So that's why it is better to first execute for the minimum. Okay, I mean intuitively it seems like minimum will for this. Now what will happen? If left is null, then you will directly return. Okay, I mean you will not do anything, you will directly return 1 plus find something and write. So I will go here and I will check if left is null. Since the left is null, I will be returning, okay, this will be returning 1 plus find something and write, and find on the right it is actually null, so it will be returning 1 plus -1, so it will be returning 0, right? So basically it will be returning 0, and then it most probably it will be returning something extra, right? 0, I mean some more than 0, right? Most probably it will be returning more than 0. Then most probably the answer will be 1 plus minimum of something like this, right? So 1 plus minimum of this, right? So it will be basically 0, then it will be 1 only, right? So for this particular node I'm getting 1. Okay, I will be executing this, don't worry, but for this particular node most probably I will be getting 1. 1 means, let's just check which option should be correct. Label of nearest leaf to the root, right? So they have defined this particular function, and then they are trying to say that, okay, so it will be returning label of nearest leaf. So since it is the nearest leaf, right? It is the nearest leaf, so they are returning label, right? So this is on the first level. If this is assumed to be on the 0th level, then this is on the first level, right? So label of nearest leaf to the root. So yes, so it seems to be true, but let's just execute on this also. Okay, and then let's just see that what should be the answer. So let's just execute on the complete tree. Okay, so most probably A is the answer, but we will be executing on the complete tree to finalize that this is the only answer. Okay, so let's just have this tree again. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, let's just have this tree again. Now let's just try to execute this. You go here, and then you will be trying to execute. Then you will say that, okay, you will find out the minimum of this and this, right? 1 plus minimum of this and this. Now if you go here, you will be saying that, okay, 1 plus minimum of this and this, right? And if there is only one node, then it will be returning what? 1 plus, since left is null, right? It will be returning since left is null. Then right will be anyway returning -1, then right will be anyway returning -1, then -1 plus 1, it is 0, right? This node, the leaf node, if this is the only single node, then it will be anyway returning 0, right? It will be returning 0, it will be returning 0, right? Both will be returning 0. Then what this 4 should be returning? This should be returning a minimum of 1 plus left and right? So 1 plus minimum of left, what left is returning 0, and what right will return? If this is null, then this will be returned by -1, right? So it will be returning, right will be returning -1, and left will be returning how much? 1 plus minimum of, sorry, left will be returning 0. So something like this. So I think this will also be returning -1 plus 1. This will also be returning 0. Is this correct? This 4 should also be returning 0, because here you will be getting -1 from here, right? Sorry. So what will happen if you look at this 4? See, for the leaf node, let's just agree all that for the leaf node we will be returning how much? We will be saying, if this is a leaf node, right? Then left, since left is null, so it will be 1 plus right, and right will be anyway -1, so it will be 0. For the leaf node, it is fine that it will be returning 0, right? And for the 4, what should we be returning? Let's just check again. Since left here is not null, neither this is null, nor left is null, right? That is why it will go here. Okay, since right is null, so it will be returning 1 plus find something on the left. Okay, so it will be returning 1 plus whatever left is returning. So left is returning anyway 1, so anyway 0, right? So it will be returning 1. So that is why 4 will be returning 1. Why? Because this is basically 0. It will be returning 0, and since the right is null, that is why it will be calling this. Since the right is null, that is why it will be calling this. It will be saying that, okay, 1 plus whatever this left is returning. If right is null, then I will be depending on the left. If left is null, then I am basically depending on the right, whatever right is returning, right? Okay. So basically, since right is null, so I am saying that, okay, whatever left is returning plus 1. So it will be returning 1. So it will be returning 1. It has returned 0. Now what about 2? So since the leaf node is returning 0, so 2 will say, my left is not null, neither my right is null, right? So for the 2, neither left is null nor right is null. So neither left is null nor right is null. So that is why it will be returning 1 plus whatever minimum of this. So I will go for the minimum. Okay. So since I'm going for the minimum, that is why this is not required. So I will be saying I will be returning 1. So my minimum will take over here. Okay. Minimum is anyway 0. So that is why I will be returning 1. Now what this will be returning? Since leaf are returning 0, it will say, I don't care what you are returning. I will just say that, okay, 1 plus whatever my minimum is returning. Minimum is basically 0. So it will say that, okay, 0, 1 plus 0. So it will be returning 1. Right? So definitely I'm doing minimum or maximum, something like this. So that is why it cannot be total. That it cannot be total for sure. And since I'm doing the minimum, that is why it is a nearest leaf. Okay, I'm just going for the nearest leaf, not for the farthest leaf. Okay, what if I have maximum here? Then it will be the farthest leaf. Why? Then in that case, I'm basically concerned about what is the maximum, what is the farthest away. If I have maximum here, it will be the farthest leaf. Okay, since either I'm doing minimum or maximum, that is why it cannot be total. So hence A is the correct answer here. Okay, understood. Great. Okay, now let's just see this question. What this question is saying, that int A is stored in the virtual address this. Okay, so this is basically one virtual address. There is some variable which is belonging to some virtual address this. This is where int A is stored, and then int B is stored at some other virtual address, which is this. This is int A. This is int B. Okay. Now what they are saying is the size of page is 0x. So basically page size is also given. Let me write here. Page size is also given as 0x 1 000. Then A's physical address is numerically less than B's physical address. So basically this is the virtual address of A. Okay. And this is the virtual address of B. So since only one page size is given, right? Only one page size is given, right? I mean, there are like from the context of the question, it is clear that that they are talking about only one program, right? Because there is only one page size is given, and also like I mean, the virtual address space also seems to be, relevant for each other. So basically, only one page size is given, and from the whole question, it was clear that they are talking about only one program. But still, few students commented that they could belong to the different program. So for future aspirants, I have written this explicitly. But otherwise, in the question, let's suppose. If they do not write it, okay, if they do not write it, then also it should be clear that they are talking about only one program, because from the most of the time it is clear from the context of the question, okay. But still, if this kind of question comes in gate, probably we can claim that they can give either A, okay, since the original answer was A, or since D is also one of the option, so they can say either A or D, okay, could be both the answers, something like this, right? So they we can challenge, and then we can say, okay, either A or D, both the answers. But for the future experience, I mentioned that both are belonging to the same program, okay. But don't worry, in the gate, if you like, we can, if this kind of question come, then we can always challenge this kind of question, right? By the way, I've taken this question from Standard University only. Let me just also put that link for your satisfaction. That is taken from CMU, basically, okay. So this particular question I've taken from CMU. If you check this link, you will be finding this question from on the CMU website, okay. Now let's just solve this question, assuming that they both belong to the same program, okay. So let's just see what's going to happen. Now see here that it is easy question only in that case. So now what they are saying, let's suppose you are having this integer, and which is having the virtual address something like this, right? Now the next integer is having virtual address something like this. Now see, see, they both has to be in the same page only, right? Why? Because the page number will be basically like this. So this is the first page, and this is the first byte of the page. So it will be 0, 0, 0, all the zeros, right? So this is the first byte of the page. First byte of first page, right? Now since there are like in the hexadecimal there are 1,000, right? These many bytes are there. So basically, if you write in the hexadecimal, then the next page, okay. I mean, just for the 1 minute, just assume this is decimal, just for the sake of explanation. Then there will be, you can say 999 bytes will be there, okay. And then the first byte here will be 1,000 number, right? So what I'm trying to say, in the hexadecimal I will come, but in the decimal, what I'm trying to say, that the page, since the page size is multiple of 1,000, then basically you can say that the starting address will be multiple of 1,000. It will be 1,000 aligned, or in other words, if you say the hexadecimal, then you will say the starting of any of the page, okay, any of the page, starting byte, any of the page will be having 3 zeros only. So basically, in the hexadecimal, if I talk, that starting byte of any of the page will be having 3 zeros only. And then let's suppose, see, let's suppose in the hexadecimal, if I talk, then let's just talk on the hexadecimal only. Let's suppose this is the page 1, okay, or page 0. Then this is basically 3, 4, 5, 6, 7, 8, okay. So before this 3, there are like 1, 2, 3, 4, 5, okay. So basically this is 0x, and then 1, 2, 3, 4, 5, and then I would like to write these 3 more zeros, okay. This is the first byte address. What is the last byte address? Can anyone tell me? What is the last byte address? Or if I just ask you, what will be the address of first byte here? The address of first byte here will be 0x 0000, and then you just need to add 1,000, right? I mean, in the hexadecimal, it is not 1,000, but yeah, you just need to add 1 and then 3 zeros, okay. Then this is the address of first byte here. So which means it will be 1, and then there will be 3 zeros, okay. Now what is the next byte address here? See, for the next byte, this will remain same, 0x0000, and then this will remain same, right? This will remain same. Then you will be just playing around this, right? So you will be just saying that the next byte address here will be 001. What are the next byte address? 002, and then so on. What are the last byte address? FFF, right? This is the last byte address of this second page. I mean, what I'm trying to say, you don't need to convert that to decimal to do all of this. You can directly see in the hexadecimal that this is the first byte address of some page and this is the last byte address, right? So basically for the first byte, if this is, I mean, these numbers will be same, basically. These numbers will be same. Okay, these numbers will be same for all the bytes. You will be just playing around this within the page. Within the page, you will be just playing around this. Is this okay? Last three you can say hexadecimal digits, right? Or last three octets. Is this okay? So basically for any given page, right? It will be starting from this number could be anything. Although this number could be anything, it will be starting from 3 zeros on the rightmost, and then it will be playing around these, right? Now now if you notice that this is same, right? This is same. This is same. It means what? It means what? See, last three, or you can say 4 into 3, last 12 bits, right? Last 12 bits are basically page offset, right? So it means if this is same, it means that they are from the same page only. If this is same, they are from the same page, right? And since this is C, this is D, this is C, this is D, it means that A is coming first and B is coming later on, and they are from the same page. They are from the same page, right? And A is coming first and B is coming later on. Okay. So this is the conclusion that I would like to make here. If you just notice, these all the things are same. So basically, you will say that A physical address. So since A is coming first, right? So let me go here again. See, since A is coming first, so A's physical address will be lesser or larger than B. Can you tell me? In a page or in a frame, it will be stored like this. Okay. And here, this is the increasing one, right? Because A address is lesser. So A virtual address is lesser, then physical address will also be lesser, right? A physical address is less. Yes. Since the virtual address is lesser, and it will be directly fitting. It will be directly fitting. So the physical address will also be lesser. So basically you will say, yes, this is always true. Okay. No, we have to. Obviously, pages are page. This is the page size, right? I mean, you will be dividing your address space like this. This is a page 0, right? As I told you, as I just told you, this is a page 0. Okay, you can't just start dividing like this from the between. Okay, you will be dividing your address space like this. This is a page 0. So page 0 will be having something like this as address, and page 1, this is a page 1. So page 1 bytes will be looking like this. Okay, addresses of page 1 bytes will be looking like this. Okay, now let's just move to the next question. So what this question is saying, in a 32-bit system, this is a little bit Indian system, right? And the at address 1000, there is some number that is being stored, and binary representation of that number is given. Now how you are going to store this? See, you have, let's suppose this is 1, 2, 3 and 4 byte number, right? So it will be stored in memory like this. Okay, you will be storing in the memory like this. At address 1000, you will be storing something. Address 1001, address 1002, address 1003. Okay, it will be taking 4 bytes. That is for sure. Now let's suppose these are the 4 bytes here. This is 1 byte. This is a second byte. This is a third byte. This is a fourth byte, right? Now, will you be doing something like 4 factorial ways to represent or something like this? No, there are not 4 factorial ways. There are only 2 ways. Either you will be storing directly. Either you will be storing this directly like this. Okay, that is called big Indian system. Okay, so basically, let me just tell you that. Let's just go to the next page. So there are not 4 factorial or something like this. Okay, there are only 2 ways first of all, and then how both of the ways works. Let's just see. Okay, how both of these ways work. Okay, see. Let's just copy this again. See what is happening. These are the 4 bytes that you have, right? So this is the byte number 1. This is the first is this is the byte number 1. This is just a binary representation. Okay, this is not a storage. Okay, I have not stored this till now. This is just a binary representation. Okay, these are the 4 bytes I have. So how to store these 4 bytes? Now there are two systems. One is called little endian, another one is called big endian, right? So how does it work? Is something like this. I will be storing, if this is big endian, then I will be storing this directly. Okay, I will be saying that okay, this is stored here, this is stored here, this is stored here, and this is stored here. This is called big endian system, right? Now there is another system which is called little endian. Okay, using little endian system, you will say that it will be stored something like this. If that is the case, or maybe I can just show you with the same diagram. If that is the case, then you will be storing like this. You will be storing this not directly here. Basically, this will be stored. Okay, this will be stored here, and this will be stored here. This will be stored here. This will be stored here, and then this will be stored here. Okay, so not directly. So maybe this diagram is getting little messy, so that is why I can use something like this. So I will say that it will not be stored directly. Okay, so this will be stored at last in the little endian. This will be stored at the second last. This will be stored at the third last. This will be stored at the fourth last. So basically they are asking you that what is the byte that is stored at 1002. At 1002 you will be storing this. Okay, which is 00110100. This is the byte that you will be storing at 1002. That is the question. But now they're asking the answer in the decimal, not in the binary. Okay, is this okay? So what is the answer? I think this is basically 2 power 4. So it is 3 into 2 power 4 plus this is 2 power 0, 2 power 1, 2 power 2, right? 2 power 2. So which is basically 48 plus 4, I think 52, right? So 52 should be the correct answer here. Let me know if that is understood. So let me know if there is any doubt here. Okay, so we have just understood both of the systems, little endian and big endian. So by the way, this kind of question can be asked in GATE. So they have recently started focusing on little endian, big endian systems. So that is why I have put this question in test series also. They've recently started focusing on little endian, big endian. Now it is fine to everyone that how both of these systems are working. This is big endian and then this is little endian. Okay, recently only they started focusing on these concepts. I think earlier also they have asked, but yeah, recently they have started focusing. Okay, now let's just see this. So in this question, they're just asking the follow of S, E and Q, right? So if you notice that all the follows will be just same and which will be dollar only, right? So for the follow, what should we be doing? We should be basically checking that where it is coming on the right hand side. Since S is not coming on the right hand side, so follow of S is just dollar, right? What about follow of E? It will be same as follow of S, and E is same as follow of Q. And what about follow of Q? It will be same as follow of S. What about follow of Q? It will be same as follow of E. So basically all follows are same as follow of S only, which are dollar. So that is why B is the correct answer here. Okay, is this understood? Okay, great. Now let's just move to the next question. Yeah, this question was interesting one. How many of you were able to solve this question? This was basically the graphic question. How many of you were able to solve? So in this question, what they're asking is that which of the following is true regarding the relationships between the elements. So here, I hope this question completely visible. If not, let me just go to the next page. Okay. I hope now it is visible, right? Now here it is given that x is greater than y. Okay, it is given that x is greater than y. See, generally in heap, there is no relation between left side or right side. Okay, but they have given this that there is a relation between x and y. Okay, there is a relation between x and y. Generally in the heap, there is no relation between x and between left and right. But in the question, it is given to you. Now let's just see if that is the case. Then what is the which option is true? So see here, they are saying which could be true. See, let's assume that since this is a min heap, let's just assume this is 1, and then this will be increasing order, right? Since this is a min heap. Then let's just assume this is 10, x is 10. Then let's just assume y is 5. Okay. I mean, you can assume any number. So, but just for the simplicity, I'm assuming like this. Now tell me, they're asking only about these two symbols. Okay. I mean, this chai, this is mocktail, right? Some hot tea and some, some cold drink. So this could be tea, this could be some mocktail, cocktail, whatever. Okay. So basically, what they're asking, the relationship between only these two symbols with the x. Tell me, can x be greater than this particular hot jar? Can x be greater than this? They are saying just could be. See, since this is 5, this has to be less than, right? This should be something like 4 or something because all numbers are distinct. So this has to be lesser than that because this is a min heap and it will be in increasing order. So it should be something like 4, right? Then x has to be greater than this. So that is why this is true. X has to be greater than this. And that is why this cannot be true. Actually, this cannot be true. Why? Because x is basically strictly greater. Actually, generally there is no relationship, okay, between this left and right. Generally, there is no relationship between left and right. If in general, let's suppose this relationship x is greater than y is not given in this question, then all of this is true. Because all of this are from the right hand side and x is from the left hand side and x is from the right hand side. If this relationship x is greater than y is not given in the question, then all of this is true. But since this x is greater than y is given in the question, in that case you will say that okay, x has to be greater than this, x has to be greater than this, right? It cannot be lesser. So that's why this is false. What about this? Can x be greater or lesser than this? Okay, let's just check. Let's suppose this is 4, this is 5. Can this be 11 or something? Yeah, it can be greater than x, right? I mean, since this is min heap, it can be, even the maximum number. This can be greater than x. There is no harm. I mean, x is greater than y, that is getting satisfied. It can be greater than x. It could be 6 also, right? It could be 6 also. So this particular element could be 6 also, or maybe could be 7, 8 also. Let's suppose this could be 7 also. Could be 20 also, right? So that is why this could be true and this could be true. But C is not true. Okay, C is not true. C is false. Easy question, but still, I just put it for 1 mark, right? I just put it for 1 mark. Right? Okay, some people are saying they ignore this could be. Okay, they ignore this could be. Let me just check what will happen if you just ignore this could be. So if you just ignore this could be, let's suppose you say which of the following are true. Okay. Then we have just seen that x has to be greater than this. Okay, or always true. Maybe okay. In that case, always okay. Then C and D. I mean this B and D will be actually false because either this or this, anything can happen. Okay, got it. Okay, in case of could be, you have to, that's why I've made it capital only, right? Could be true. That's why I made it capital only. Great. Because all, if you say always true, then we cannot say anything about these symbols. We can only say about this particular thing, right? For the always, we cannot say anything about this particular drink. Let's just see this question. Or they're saying it is possible to create a tree that is both binary search tree and heap. What is the maximum? What is the maximum number of nodes in such a tree? So they are saying that, so, like, if it is possible to create, let's suppose, binary search tree and min or max heap, you can take any heap, doesn't matter. So let's suppose this number is 5, anything, right? For the binary search tree, it should be lesser than 5. Here it should be lesser than 5, so it could be 1 or 2, right? 1, 2, anything, right? And this should be greater than 5. This should be greater than 5. Now if you are taking min heap, then obviously lesser than 5 won't work, right? I mean, the lesser than 5 won't work. So let's suppose you are talking about the max heap only, right? If you're talking about the max heap, in that case, what will happen? Then you will say that, okay, you can put 5 here, you can put 2 here, for example. And then, since all the levels of heap are full, you cannot go to the further level until you fill this, right? Then for the binary search tree, it has to be greater than 5. But for the heap, it cannot be greater than 5, right? So in that case, what will the answer? So basically, you can just have this. So that is why 2 is the correct answer here. I mean, the moment you have this, it will be greater than 5. Okay. So that is why 2 is the correct answer here. Okay. What about if you take min heap? In case minimum will be here, and then all the numbers will be greater, right? All the numbers will be greater. So in case of min heap, you cannot have greater elements for the binary search tree on the left hand side. So in case of min heap, there could be only one. I mean, there could only be one node. Okay. I mean, you cannot have more than one node. I mean, you can just have minimum number. The moment you try to have more nodes, basically what will happen? You need to, for the min heap, you need to put greater than 1, but greater than 1 is not possible in case of binary search tree, right? So in that case, it will be just only one node. But yeah, currently 2 is the correct answer. Okay. Now let's just see this question. Which of the following statement is true about the Huffman coding? In Huffman coding, the item with the second lowest probability is always at the leaf that is furthest from the root. Okay, so let's just check this. The item with the second lowest probability is always at the leaf. See what you do, you take the lowest probability, right? Which is the, let's suppose this is the lowest probability and second lowest probability, and then you merge them, right? Then you will be start drawing your tree. So basically, you will be merging it. Now, in that case, if you merge it, then what will happen? The second lowest will be on the leaf only, right? The second lowest, whatever is the second lowest node with the probability, it will be on the leaf only. So that is why A is true. Okay. Okay, I will come to your argument. There are a few people are having the argument, so I will come to that. Let's just check this B. What this option is saying, in Huffman coding, the item with the highest probability is always at the leaf. Okay, that's not obviously true. Let's suppose there is some item with the highest probability, which, let's suppose 1 by 2, right? So you will be start taking let's suppose there are many items, 1 by 8, 1 by 8, 1 by 8. You will be first start taking the items which are having the lower probability, right? And then what they're saying, if this is the highest probability is always at the leaf, that is the child of the root node. Okay, so will you be taking just at the last? Need not to be, right? I mean, in this case, it could be like this. But let's suppose there are, like, you can merge these two, and then you can merge, let's suppose, these two, and then maybe or maybe you can merge these two, and then you can merge these two, right? Let's suppose these are coming 5. I mean, I will convert into the probability, but let's suppose 5 5, and these are 6 6, right? So you can merge. This is 10. They will be merging like this. This will be 12, and then this, right? So basically, this item, this particular item, if you can convert to the probability, this is basically having the highest frequency, which means the highest probability, right? You can convert to the probability, doesn't matter, 6 by 6 plus 6 plus 5 by 5 plus 5, okay, like this. Okay, you can convert to the probability. But what they are saying, but the highest probability is always at the leaf that is child of the root. Okay, that is child of the root. No, it is not the child of the root, right? So it is obvious. So that is a B is false. If frequencies of the letter are equal, okay, then if let's suppose the frequencies are equal, then ABC then is a valid Huffman code. So if these are having just 3 letters, as you can check, then A and B will be merged, right? A and B will be merged, and then C will be merged like this, right? So basically A and B will be having, or maybe any two, right? These any two will be having basically 2 0 1 like this, 0 1 0 0, okay, but this C will be having just one, okay, C will be having just one, right? So that is why this is false. Okay, so this is false, this is false, that is why this is false. So A is the correct answer here. A is the correct answer here. Now some people are saying in A, they are saying, what if you are having the equal probabilities, right? So let's just rewrite this option A. Let's just rewrite this option A. Let me copy paste. So in option A, they are saying, in Huffman coding, the item with the second lowest probability is always at the leaf. Okay, so some people are giving the argument, which is actually understandable, but let me still write it. So basically they are saying, let's suppose take a item with the probability, let's suppose 2 by 3, and B is having the probability 1 by 6, C is also having the probability 1 by 6. So they are saying that A is having the second lowest probability, right? And that is not the farthest away from the leaf. So basically you will be merging B and C, right? And this is 2 by 6 or 1 by 3. And then you will be merging that with A, right? So since A is having the second lowest probability, that is always at the leaf that is furthest from the root. So it is not the furthest from the root. So I mean, this argument is kind of valid. But this question, by the way, I have taken from Berkeley. I have also put the link in the comment. Let me just put that link here also. So I have taken the same statement from the Berkeley, and they are the basis on which they are giving the answer, I will also tell you. Okay. So they are saying this is true. So generally what I observed, I can tell you this, that whenever you have, let's suppose the element one, let's suppose there is an array, okay, 2 3 like this, right, 4 5. If you ask me what is the lowest, okay, what is the lowest number, 1, what is the second lowest number in this array? The second lowest number in this array is 1 only, right? Second lowest number in this array is 1 only. The lowest is 1 only. Lowest is also 1. Lowest number in the array is also 1. But second lowest is also 1. Okay. This is lowest. This is also second lowest. So basically lowest and second lowest are same here. This is the third lowest. This 2 is not the second lowest. This is third lowest. Okay. On this basis, like, I mean, I think this is generally true. I have also observed few of the questions regarding the heap in previous year gate questions, and there also, this kind of argument is always valid. So even at the stack overflow and these things, they assume, like, whenever they have to assume, okay, what is the second lowest, third lowest, they assume like this only. This is what I have observed. Obviously, currently, actually, I don't have. I have observed over the time. So currently, I don't have those links. Whenever I have the link, I will put in the gate overflow discussion community. But based on this only, Berkeley has given the answer. Okay, they have given the answer based on this only. They are saying this is true. Okay, this question is taken from Berkeley. Right. So basically, they are saying that this is the lowest, this is the second lowest, and second lowest and lowest are same. So lowest and second lowest is same. Right. So here here you will say lowest is this and second lowest is this. Okay, which are same. So second lowest is always farthest away. Yes, that is true. Right? First and second lowest actually both will be the farthest away from the root. That is also true. Okay. Maybe in the exam, if in the gate exam, if this kind of question come, probably you can challenge it, but that is not sure. See, if that is sure that they will accept it, then I will tell you. But here we are not sure they will accept it. Okay, here we are not sure about it. Okay. Now let's move to the next question. Okay, let's see this question. What this question is saying. This is question number 28. They are saying let A be this and B be this. For which of the value of k, ax equal to b has a unique solution. So what you need to do, you just need to basically put this in the augmented matrix, I think. Okay, sorry. Yeah. So basically you just need to put this in the augmented matrix. Okay. And then you have to do row reductions. And finally, let's suppose you are coming like this, right? You are coming like this. So you are coming like this. So for what value of k, it will be having some solution, by the way. It will be having the solution for -1 minus k equal to 0, right? Then only it will be having the solution. And what is the question? They are saying ax equal to b has a unique value. So actually they will be having the solution. There could be the unique value only. Why? Because they are like, these two are linearly independent. These two are linearly independent. These two are not dependent. So there will be unique value only, and which will be at k equal to 1. Okay. Sorry, -1. K equal to -1. Understood? Let me know if that is okay to everyone. Okay. Now let's see this question. What they are saying, let x be a random variable that is taking the value -1 and 1, and probability of x being -1 is 1 by 2. Right? And that is obvious that probability of being x equal to 1 is also 1 by 2, because x is only taking two values, right? So x, probability of x being 1 is also 1 by 2. So what is the expected value of this x square? So what is the expected value of x square? You can say that summation over all, values of x square into probability of x being x, right? Which is basically 1 minus 1 square into 1 by 2 plus 1 square into 1 by 2, which is 1 by 2 plus 1 by 2, which is 1. Right? That was easy question, I think. So by the way, what does this rule called? What is this rule called? Do anyone know what is this rule called? This is called lotus, right? Law of unconscious statistician, something like this. Okay, so maybe you don't need to know about this rule, but yeah, if someone knows about this rule, or someone has seen the lectures, I've told this rule in the lectures. That is called lotus. Anyone remember that I told this in the lecture? Yes, great. So there are like comments, right? So people remember. I'm really happy to see that people remember. Okay, that is called law of unconscious law law of the T means the, okay, law of the unconscious substitution or statistician, something like this. Okay. Not unexpected. It is unconscious. Okay, because unconsciously we in the subconscious mind, with the subconscious mind we do this. So it is just a fancy name. Okay, lotus. Now let's just see this question. I think this question was easy one. Okay, the better way to solve this question, instead of solving like this, you can say that this is nothing but probability of x plus y greater than or equal to 1. this is nothing but 1 minus probability of x plus y less than 1, right? It means that x can take, since x can take the value 0 or 1, y can also take the value 0 or 1. So less than 1 basically is possible. It means that 0, they both has to be 0 only, right? I mean, less than 1 is the only, the 0 is the only case here. So basically, this is same as 1 minus probability of x plus y equal to 0, right? And which means both are actually equal to 0. So this is same as probability of, no, this is true only when x is 0 and y is 0. So this is same as, let me write it. This is same as 1 minus probability of x is 0 and y is 0, right? So which is p into q. So that's why the D is correct answer. That was easy question, but yeah, nice question. Okay. That is the reason I have put in this question in 1 mark. Okay. Now let's go to this question. So in this question, they are saying g of minus 1 is something like 4. So g of minus 1, which means this is minus 1 and this is 2. G of minus 1 is 4. Okay. This is 4. And then g of 2 is 7. Okay. So this is g of 2, which is basically 7. I mean, you may have anything in between, but yes, this is something like this, right? I mean, in between, it could be anything. Could be like this, could be like this. Okay, it could be anything. It could be anything, right? In between, it could be anything, but yeah, in general, it is this. So now they are saying GC. Okay, let's just first talk about GC. GC. Can it be 1 or 0? Is it necessary that you should be having GC? I mean, the value of the function should be basically going down. Okay, I mean, it is necessary it should be 1 or 0, something like this. Is it necessary that function should be decreasing at some point in time? No, right? I mean, function could be like this. Function could be definitely like this. Could be like this, right? So GC, which means the function value itself has to be 0 or has to be 1. So that is why we cannot say. We will say that it need not to be 1 or 0 or something like this, right? It is a polynomial function. So if it has to go like this, basically, it has to be going like this, right? But it may be going like this. Basically, what I'm saying, it may be going like this. It may be decreasing. It may be increasing. We do not know, basically, right? There is a value, there is some value for which you will saying it is touching 0 or it is touching 1. It need not to be the case, right? So function could be always decreasing and suddenly it could be increasing. It could be like this also, right? So we cannot say about GC whether it is 1 or 0. What about G dash C? What about G dash C? Okay, what is the slope? Okay, should it be at some point in time will it be 1 or 0? So let's just check about it. So we know from the mean value theorem, right? We know there is one theorem which is mean value theorem. Can you tell me how to answer this question? We know one thing, which is G dash C equal to, let me go to the next page. Maybe I can just solve here only. G dash C equal to G of 2 minus G of minus 1 upon 2 minus minus 1. Basically, it means that it is a slope, right? Slope of the curve. I mean, there will be some point C which is basically equal to whenever you are having minus 1, between minus 1 and 2, right? So basically, this is G dash C, right? G dash C is nothing but it will be basically, if you just touch these two, then whatever line you will be getting, okay, slope of that line, there will be some point for which it is equivalent to the slope of that line. There is a theorem, right? You know this theorem. So from this theorem we can say that this is 7 minus 4 divided by this is 3, so it will be 1. So we know that G dash C should be 1. Okay, there will be some C for which G dash C should be 1. So that is why B is the correct answer here. Okay, is this understood to everyone? Okay. Now let's see this question. This question was related to minimum spanning tree. Okay. And then they are saying that this particular, table is given here, or you can say adjacency matrix is given here, right? Now, now here they are saying it is a complete graph with 6 vertices. See, this question was kind of unique in the sense that they have not given the graph. Instead, that they are just given the weight matrix, right, or the adjacency matrix. And now you have to find out the minimum spanning tree. So people have used Kruskal, but for me, intuitively, it seems like we should be using the prims here. So you can start with any vertex. Let's suppose you are starting with one. Okay, you can use, most probably you can use Kruskals also. We can solve this question using Kruskals also. But personally, I would prefer if we solve this question using prims. Okay, you will see why. I mean, for me, prims is more intuitive. Why? Because if you start from 1, so what is the minimum? See, this is a symmetric matrix, don't worry about this. Okay, what is the minimum among all of this? This is 3, so 1 will be connected to 5. Okay, I mean, using the min cut, right? So you will say that if I have to connect this 1, then 1 should be connected to 5 only, right? 1 should be connected to 5 only using this 3. Is this fine? Now you can check about 1 and 5. So you just check about 1 row and 5 row. Okay, so don't worry about this. So you can basically, this is a symmetric matrix. So just check 1 row. What is the minimum here? So don't worry about this 3. Okay, and don't worry about for this 5. Yeah, that is fine. So don't worry about this 3. What is the minimum in the one row? This minimum is 5. Here the minimum is 7. So you will say, okay, I think 1 and 4 will be connected with 5. Okay, is this fine to everyone? Okay, so 1 and 4 will be connected with 5, with the weight 5. Let me know if that is understood. Now you can go from 1, 4 and 5. I mean, you can go with 1 row of 1 and row of 4 and row of 5. So here you will see that, okay, 4 is connected to 6 using 3. Okay, minimum seems like this. In one row, this 5 is okay and 4 is okay. Don't worry about this. 1 is also connected to 6, but this is not minimum. In the 5 row 1 is 5 is connected to 6 with 7. So I think 4 is connected to 6 with 3, right? So you will say that, okay, 4 is connected to 6 with 3, right? So 4 is connected to 6 with 3. Is this fine to everyone? Okay, now I think 2 and 3 are remaining. You can go to 2. Now you can go to 2 directly. Okay, what is the minimum here? Minimum here is basically, you can say that 6 is connected, 2 is connected to 6 with 2, right? So 2, if you have to connect, then you will be connecting 2 with 6 with 2. Is this fine? And now you can go to 3 directly. For the 3, you will say that, okay, 3 is connected to 4, 5 and 6, but the minimum is 6 only. So 3 is also connected to 6, right? 3 is also connected to, or maybe 3 is basically 3 is connected to 1, 2. Sorry, we need to check these numbers. So 3 is connected to 2 with minimum value, which is 9, right? 3 is connected to 2 with 9. Okay, yeah, 2 and 3 are connected with 9. Is this fine to everyone? I mean, you can do with the min cut, using min cut or using prims. Okay, or you can use Kruskals. Okay, for the Kruskals, if it is intuitive, then you can do it. Otherwise, for me, prims was more intuitive. Okay, so I was using prims. Okay, you can use Kruskals. So for the Kruskals, I think you will be basically taking the minimum. Minimum is 2, right? 2 and 6 will be connected. You can even use a mix of it. Okay, maybe let's just use mix of it. So see, if you use mix of it, that's also fine. In the sense that, I mean, that's not an algorithm, that's just a human way to do it. Okay, that's the humanized way to do it. So you know that, okay, using Kruskals, you know that, okay, the minimum is 2, right? So you know that, okay, this 2 and 6 will be connected. 2 and 6 are connected using 2. You know this, right? That's fine. And then, using prims, you know that 1 and 5 are connected using 3, right? 1 and 5 are connected using 3, right? And then probably then what is remaining? I think 1, 2, 3, 3 and 4 are remaining. For the 3, can you infer something? 3 and 2 are connected using 9, right? 3 and 2 are connected using 9. So you can say for the 3, I have just used min cut. 3 and 2 are connected using 9. Okay. Now what about 4? For 4, you can say 4 and 6 are connected using 3, right? 4 and 6 are connected using 3. Okay. Now I think what is remaining? How to connect this 1, 5, right? To this. So maybe I can just check just 1 or 5. So 1 is connected to 2 with 8. So here the minimum is 5, right? 1 is connected to 4 with 5. 1 is connected to 4 with 5. This is the minimum here. And what is the minimum at for the 5? I mean, this is the minimum for the 1, which is connected to 4 with 5. What about minimum of 5? 5 is connected to 1, that is okay. 2, okay. 5 is connected to 6 with 7. Okay. So obviously I will be taking this. Okay. You can use some mix of intuition and all, right? So, I mean, this was easy question, but interesting one. So if you check the total cost, it will be 8 and to 10, 10 plus 3, 13, 13 plus 9 will be 22, right? So 22 is total cost. Okay. So you can use mix of it. You can say that, okay, let's just check how 2 is connected. I got to know. You can just first pick the minimum. Maybe you got to know, okay, this 4 and 6, or maybe 4 and 6 are connected using 3, right? Or maybe 2 and 6 are connected using 3. Sorry, 2 and 6 are connected using 2. So this is the minimum. 2 is minimum. So you can first take this minimum, and then you can use mix of primes and crows or some intuition, and then you can find out this, right? So this was kind of unique question in the sense that generally we have the tree, but this time I tried something else. Okay, I thought that, okay, instead of tree, let's just give them adjacency matrix. Hope you like this question. How many of you like this question? It was easy question, I agree, but yeah, this was interesting to me. So I think this right hand part is little bit not visible, but now I think this is visible, right? Okay. Now let's just move to the next question. Yeah, this is one of the interesting question. Okay. By the way, how many of you has watched our? There was one marathon. Let me first fix the dimension here little bit. Okay. There was one marathon. How many of you watched that marathon? In that marathon, I have solved this exact same question. Let me just tell you. The marathon I have taken last year. Let me just put the screenshot of that marathon. Okay, this is very nice marathon that has got 18,000 views. And it is very nice marathon. So see here. Okay. So you can watch this marathon. In that marathon, I have solved all the questions from asymptotic notations. In fact, one of the exact same question. Do you know this? One of the exact same question has come in GATE 2024. And this marathon I've taken just before GATE 2024. Exact same question from this marathon was in GATE 24. Do you know about it? Maybe I can just tell you from one of the comment. There should be one of the comment. I think, okay, that was related to recurrence relation. I think that is in another marathon, but that is fine. Okay, it was related to recurrence relation. The marathon I'm talking about. Okay, the recurrence relation exact same question has come in the gate also. Okay, so now let's just talk about this particular question. So also let me put one screenshot because that question I have already solved in that marathon. Yes. If you check around this particular time stamp in this marathon, then you will be finding this question. Okay, this question I have given in AIMT, but I've also given this question last year in one of the weekly quiz. This year I have not given this question in the weekly quiz, but last year I've given. So last year I've solved this from the weekly quiz. Okay, so at around this time I've solved the same question here. Okay, but now let me solve it again. Now let me solve it again. So what this question is saying, let's just see this. Okay, so this question is saying that if you have two functions which are the positive increasing functions, okay, because for the negative functions generally there are too many arguments, so that's why I don't want to get into this. That's why I said these are the normal functions, I mean the algorithmic functions. Algorithmic functions means you have always time complexity obviously greater than 0. How you can save the time, okay, how you can run the algorithm and go to the back in the time. For example, you are running the algorithm today, let's suppose at 12 p.m, and or maybe let's suppose at 1 p.m, and after running the algorithm you got to know, oh, now you are at 11:30, right? And now you are at 11:30 p.m. Obviously it can't happen. So for the algorithms the time complexity are always positive, right? Now let's just see this question. Now what they are saying, let's suppose, see, this question is revolving around only one concept, that suppose given that relationship between fn and gn is small or capital O, then after taking log or after taking power, what you can say, right? So let me just tell you that suppose there are two cases. Basically this question is revolving around two cases only. Case one, suppose this fn and gn are related like this, are related from small o. Okay, this is small o, right? This is case one. Case two is that suppose they are related from big O. Okay, given that they're related from big O, then what can you say? What can you say after taking, let's suppose, after taking log, then what can you say about the log? Okay, log of fn and big O, or the power. So let's just talk about it. So suppose we are taking the log here. Okay, suppose this is the case one. I'm talking about the case one. Suppose we are taking the log here, log of fn. Then what is the relationship between log of fn and log of gn? Can you tell me? See, if we are already saying that gn is far greater than small o, means there's a function greater, right? I mean there should be multiplication of function. So basically fn is strictly lesser than gn, right? This is what I'm saying. This is basically far greater. Okay, gn is far greater, function greater. Now after taking the log, what do you think? See, log is increasing function, isn't it? Let me just explain this. Let's suppose if I just ask you for one thing. Let's suppose there is one number which is 2 power 20. There is one number, this is 2 power 40. Okay. After taking the log, suppose 2 power 20 is lesser than 2 power 40. After taking the log also the relationship hold, isn't it? After taking the log also, let's suppose, but this gap is huge. Okay, there's a huge, this is greater by a huge margin. But after taking the log, this is 20 and this is, let's suppose, 40 only. This is still greater, isn't it? This is still greater, but with the less margin. This time it is greater with the less margin. Do you understand this? Let me know. Is this fine to everyone? Right? So this is still greater but with the less margin. Now, what will you say about the log? You will say after log, see, after log things are following the same inequality. This is lesser, but margin could be different, right? So basically there's a classic example. I will tell you that example also for the algorithms. So basically what I'm trying to say, after taking the log, it might so happen that it is like initially it is a huge margin, means let's suppose it is having the function, it is n greater. Let's suppose this is fn, then it could be n into fn, right? N into fn. But after taking the log, the margin could be less. So for example, let me just directly give you that example. Let's suppose there are two functions. You might know about it. Let's suppose there are two functions. One is n factorial, one is n power n. Do you know that n power n is strictly greater? Do you know this? It means n factorial is small of n power n. Okay, which is small o. Do you know this? Now, if you take log, then if you take log, then what's going to happen? After taking the log, it is numerically it is greater, but actually this is n log n, asymptotically this is n log n, and this is also n log n. Both are actually n log n. After taking the log, after taking the log, both are n log n only. This is also n log n. Okay, basically after taking the log, they are theta. Okay, basically if this margin is less, after taking the log, margin is less, so it may be theta also. They may become asymptotically, they may become equal. That is my point. Okay, so it cannot be reverse inequality. It cannot be the case that, okay, initially let's suppose fn is strictly lesser than gn, then after taking the log, can it happen? Tell me, after taking the log, can this inequality be reversed? The reverse inequality, this cannot happen, right? After taking the log, this cannot happen. Okay, but after taking the log, what may happen is this: they may be still greater. Okay, I'm not saying this will be always lesser. So see, if initially that is the case, then after taking the log, which is, if you ask me the relationship between these two, then I will say after taking the log, they may be asymptotically equal, or maybe it is still strictly lesser. I mean, this greater possibility is not there. Okay, this possibility is not there. This is not possible. I mean, this relationship can't be reversed, but they can be equal asymptotically. That is the example that I have just shown you. Okay, before taking log, it is strictly lesser, but after taking the log, they are actually equal. Understood? So this is actually one of the trickier question. So here I will say that if initially this is strictly lesser, after taking the log, okay, it cannot be greater, but yeah, it can be actually equal. That is the thing, or it can be lesser only. Okay, so basically either theta or big O. So in general, you can say it is a big O. I mean, you cannot say that after taking the log, you cannot say that it is still small o. Okay, you cannot say it is still small o. It will be big O. Okay, which means it could be greater or equal, right? So if this is initially, if it is gn is greater, strictly greater, after taking the log, is it strictly greater? No, right? After taking the log, if it is initially strictly greater, okay, so basically here big O, I think big O I have not given as an option, but yeah, so A is basically false. Is this understood? A is false here. Let me know. So this A was one of the trickier option. Okay, A is false here. Now I will come to this question. So basically here I am saying after taking the log, I hope that is clear, that it will not be small o, it will be big O. Okay, after taking the log, it will be big O. Right? I hope that is clear. What about the keeping the exponent? What about if I raise the power? For example, if this is the case, right? If this is the case, what about if I raise the power? If I just ask you 2 power fn and 2 power gn, how they are related? If this is obviously strictly greater, then after raising the power, there is no way. See, in the log only there is some possibility of some magical thing happen. Okay, if this is basically already greater, then after taking the power also, if it is strictly greater, okay, after taking the power also it is strictly greater. So you can say it is small only. Is this okay to everyone? After taking the power also, it will not be the case that it can be equal. So I do not need to say this is big O, this is small only. Right? So basically, here in this question, for the small o, after taking the power, yes, this is small only. So that's why I can say this is true. So I hope A and D are okay to everyone. That after taking the log, I cannot say it is small o, but after taking the power, I can say it is small o. Okay. Now, let's come to the second case where it is big O. Okay. Where it is big O. Let's go to this case where it is big O. In that case, what will happen? Let me just tell you. Suppose the relationship is big O. Now, if you take the log, then what will happen? Suppose if I ask you the relationship between log of fn and log of gn, what will happen? See, initially it is less than equal to. After taking the log, margin may be less, but it is still a reverse. It cannot be the reverse inequality or something like this, right? So it will still hold this kind of thing. Is this okay to everyone? . Okay, so which means it is still big O. Okay, which means I can say after taking the log, I can say it is still big O. I mean, the margin could be less, but that's fine. It could be equal or it could be strictly, I mean, this cannot be reverse or something, right? So after taking the log, you can say with respect to asymptotic, if I need to write, you can say something like this, right? So after taking the log, it will be like this. Okay. Now, what about after taking the power? That's also interesting. See, if initially it is big O, then after taking the power, what will happen? Suppose you ask me that what about this? Okay, after taking the power. See, here it is very interesting. Here it might be the case that constant may play a role in power. Okay, in power actually constant may play a role. So if let's suppose fn is n and gn is let's suppose 2n, then it is fine. 2 power n, then 2 power 2n or something like this. This is nothing but 4 power n, right? Then this is still like this. But it might be the case that constant is playing a crucial role here, right? It might be the case this is 2n and this is n. In this case, it is 2 power 2n. This is just 2 power n. This is 4 power n and this is just 2 power n. So obviously this is strictly greater. Isn't it? This is strictly greater. So basically what I'm trying to say that just because of this constant, okay, just because of this constant, things are actually changing at too much. Right? Just because of this constant, the things are changing. So basically the counter example here is that after taking the power, it need not to be like big or something, right? I mean, it could be even greater. After taking the power, it could be even greater. So basically here in this case, after taking the power, we cannot say anything, whether it is greater, less or equal. Okay. So we cannot comment. Here we cannot comment anything. Okay. Here we cannot comment anything. So that is why I will say that after taking the power, okay, this is big O. Will it be big O? Tell me. No. So B is false, right? B is false. It will not be big O. We cannot comment anything. After taking the power, we cannot comment anything. What about log? Yes, log. This is true, right? This is true. It is still big O. So C and D are true. Okay. This was a nice question actually. Understood? This was a nice question. What you can do, you can basically see this particular marathon, and here I've actually explained everything in very, very good detail. Okay. You can just watch this marathon. It has got many comments and it was actually very, very nice marathon. Okay. Now let's just move to the next question. Yeah, this was also a nice question, right? This was also a nice question. Let's just see this question. What this question is saying. So here we are saying, suppose that on a certain system, every function call puts 10 bytes on the stack plus another 10 bytes on the stack for the integer formal parameters, right? So for a function call, there is a 10 byte on the stack, and then there will be activation record, and inside that activation record, I mean, there is some formality that they have to do for that 10 bytes, and if there is one integer, then there is another 4 bytes for every integer. If there is one integer, then 4 byte. If there are two integers, then 4 plus 4. Okay, so this is for function call. These are for the integers. Okay, how many of you were able to solve this question, by the way? In the exam, how many of you were able to solve this question? See, to solve this question, what you can do, just to solve this question, I'm saying, okay, you can take some value of n, okay, if you just like to solve this question. Let's suppose n is 2, which means walk 2. So in that case, it will be 14. It is 18. This is 32 minus 18. This is something like this, right? So you can take NH2 and then you can basically solve this question very easily, right? You can just take NH2. So let's just take N2. Okay, for example, if you take N equal to 2, then what will happen? You will call walk 2, right? So walk 2 will be pushed first. So here walk 2 will be pushed, and then walk 2 is basically having only one integer, right? So walk 2 will be taking basically 10 bytes plus only one integer, which is 4. Then it will be calling run, right, with two integer run 2 comma 1, right? So run 2 comma 1 will be pushed. So here again 10 plus 4 plus 4, because these are the two integers, right? Now it will be calling walk 1, and walk 1 will be returning. Basically it will be calling walk 1, right? And walk 1 will be returning. So it will be basically 10, right? So you can say that 10 plus 30, you can say total 30 plus 12, right? 30 plus 12, right? Which is 42. 42 is needed. Or maybe I have missed anything. Yeah, walk 1 will be called. And yes, this is also 4, right? For the walk 1, there is also 4. Okay. So 30 plus 16. 30 plus 16. 46, right? For walk 1 also, there is a 4. So if you notice that 46, 32 plus 14, 46 is coming from here only, right? So D is the correct answer. But let's just solve it systematically, okay? Not just by putting the values. So if you put the values, then you can easily solve this question by saying that, okay, D is the correct answer here, okay? But let's just solve it even more clearly. Okay, just a second. Let me put this question again. Okay. So what they're saying, let's just try to understand. They're saying that you are calling walk n, right? See, whenever you're calling walk n, what will happen? This will take walk n. So every walk, okay, will take extra 4. And every run will take extra 8. Okay. So every run will take extra 8. And now this will be calling run n by 2. See, it will depend on n by 2. I mean, the termination will be depending on n by 2, right? I mean, basically, because then only you will be calling this walk again with this y parameter. So every run, you can say, I mean, you can write this n, but it actually always greater than equal to y. Okay, x is always greater than equal to y, so it doesn't matter. So you can say n comma n by 2, or I'm just writing n by 2. Okay, it will be taking 4 into 2. Okay. Now walk again with n by 2, and then 4. So basically walk will be log n times, right? Walk will be log n times. So you can say that walk will be log n times, and similarly run will also be approximately log n times, right? So walk will be log n times, and each walk is taking 4. Sorry, each walk is taking 10. Is this fine to everyone? Let me know. Is this fine? So it is basically log n times or log n plus 1 times. You can quickly check it. So I think if you take n equal to, let's suppose 2 power 2, then it is this 1, 2. So for 4, then 2, and for 1. Okay, for base condition also. So maybe it is log n plus 1 times. Okay, so you can say log n plus 1 times. So these many times walk will be called. And each function call will be taking 10 for this call and 4 for the integer. So you can directly multiply by 14. Okay. So these many times walk will be called. And run will be, since the starting of run is just from n by 2. So run will be called one lesser than walk. So run will be called log n times. Okay. Log n times. And each run will be taking how much space? Can you tell me? This will be called log n times. So it will be taking 8 plus 10, 18, right? 18 space. Okay, so this is your answer. So if you sum this up, your answer will be D. Okay, if you sum this up, then D will be the correct answer. Okay. Let me know if that is okay to everyone. Okay. So it was easy question only. You just need to observe that, okay, walk in will be called how many times, right? And then one lesser times will run in will be called, and how much each run in will be taking, and how much each walk in will be taking, right? Like that you can solve this question. So these many times run will be called. Okay. So by the way, this I have taken as it is from Standard University. Okay. Now let's just move to the next question. Let's just see this question. So this question I asked, but here I have seen few of the students are saying, what does this belong? Okay. So it is very surprising that people, I mean, few of the students, okay, do not are not aware about these notations, which is okay. I mean, I'm not saying that this is something wrong, but you should be actually knowing. How many of you have not seen the belong notation? How many of you have not seen the belong notation in the asymptotic? How many have seen this very first time that okay we can use a belong or something? Let me know. Are you seeing this belong notation very first time? Let me just tell you one thing that see there was GATE 2023 recent question, and you just see the notations. You just see the notations. There was even a recent question with these kind of notations, right? Okay. So what does this notation say? It says that basically yeah, basically it says that generally actually this is the correct notation. The equal to is not the correct notation. Okay, so basically it says that, let's suppose I write order of n cube, right? Order of n cube. It says that this order is actually, or order or any other notation, this is actually a set. Okay, this is actually a set, which means it is having anything which is lesser than equal to n cube, n square, n cube, 2n cube, okay, and n log n or whatever, right? This is a set only. A function belongs to that set only. Okay, the equal to is basically abuse of notation. Just I mean this belong notation doesn't fit very much conveniently. That is why we misuse the notation. If you check Corman, okay, if you check Corman, they have written this. If you check Corman, um, yeah, we abuse equality. Okay, this is abuse of notation. We abuse this equality is abuse of notation. Okay, so they've specifically talked about this notation thing. Even for this particular question, I will suggest you to look at the solution of this question. Okay, and the video solution is also there, and which is by Go classes only. Like I've only taught it in the course, and later on it came in the exam also. Okay, so this video, if you check the video, I think I'm not sure when did I put the video, but it was recorded before GATE 2023 only. Okay, it was recorded before the course, but if you let me quickly check, if I put it on the YouTube before GATE 2023 or later on. Just a second. Most probably I have put it before GATE 2023 only. Just a second. Yes, it is before GATE 2023. Okay, you can check this video. Here, let me just give you the link of the video also. So this video was 2 years ago. See, in this video, I already talked about these notations. Okay, that this is the belong notation. So basically, instead of writing equal, we should be writing belong, but that is fine. Okay, we abuse the notation. Okay, this is abuse of notation. This is 2 years ago, and this is actually unlisted. Still, it has got 1K views. Okay, it is unlisted, still it has got 1 k views. Now you just see the power of this video, right? Unlisted video has got 1 k views. Okay. Now just let's just continue with this question. So now I hope that is okay to everyone. That what is this belong? Belong means that I mean you can use equal. Okay, it doesn't matter. You can use every of this belong can be can be seen as equal. Okay. I mean every of this not belong means not equal, doesn't matter. So you can even use equal. But yeah, belong is the correct notation. So there is no harm in using the belong notation. Okay. So by the way, you notice one thing. We already tease the things. Let me remove it. Yeah, we already tease the things, and later on these things come in gate examination, right? So this is what go classes is doing. We tease the things, and later on these things come in gate examination. Okay, so we teach all the things, and later on basically again many of the teachers copy our thing, and then they try to claim that okay they have taught it and all, but we actually tease the things, and later on these things come in gate examination. Now let's just continue with this question. That what this question is saying. It's an easy question, by the way. Now what this question is saying, that f and theta are same. F is basically from the theta of g. F belongs to theta of g. Then you can write like this. Yes, they are asking cannot. So actually this is true. They are asking about cannot be true. This is true. If f is lesser, f is lesser than equal to, okay, less than equal to g can also be lesser than equal to. Yes, if they are theta, then it is possible. If both are n, right? If both are n, f is n and g is n, then yes, this is also true. I mean, this can be true. This can be true, right? What about this? If f is less than equal to, then g is not greater than equal to f. This is false. Actually, this is transitivity, or I mean, I will not say transitivity, but this is a rule, right? This is a rule. So it is basically saying that if f is this, then always g is belong to g belong to this. So basically, if f belongs to big O of n, then g belongs to big omega of f, big O of g, right? I mean, g is greater than equal to f, obviously. So this is always true, right? I mean, if you are saying not equal to, this cannot be true. So this is false because of not equal to. Now they are saying f is not related to g. Okay, not any of this is not related to g. G is also not related to f. Yes, that is true. How? I mean, there are functions that are not related to each other. For example, let's suppose there is some function, right? This is some function which is fn equal to n. Okay, I mean some function just like this. Okay, just a linear function. Now there are functions which are neither always above nor always below. Okay, let's suppose there is function that I define like this. Okay, they're neither always above f nor always below f. Okay, they're oscillating. Let's suppose this is g. This is g. Then I will say f and g are not related to each other. So it is possible to have no relation between f and g. Okay, it is definitely possible to have no relation. Is this fine to everyone? Okay. Yes, I don't know what will be this plot, but I think it could be some n plus sine n, something like this. Okay, n plus sine n, something like this. Most probably it is something like this. Okay, I mean there need not to be exactly relationship between f and g. Okay, always. Understood. Okay. Now let's move to the next question. So by the way, this GATE 2023 question, you can definitely try this question. Because one of the student actually commented that how we can basically say belong notation. So one of the student has commented. Let me even show that comment, and I have replied. So in the AIMT question, in this particular question, they commented how the function belong to another function. Okay, this is not belonging to another function. This is belonging to order. Okay, theta, something like this, right? So I've commented with the link of this question. GATE 2023 question. Okay. Now let's just solve this question. This question I think was easy question only, right? So I just need to put my laptop on charge, and just let me just check how many questions are remaining. So maybe few of the questions are remaining. So let me just quickly put my laptop on charge. Okay. And then I will just continue. So can we have 5 minute break? Let's just have 5 minute break. Okay. So let's just meet at 4:30 and then we will be just continuing. Okay. Hi everyone. Okay, so now let's just continue. So sorry for little delay. I was just having lunch. Okay, so now let's just continue. So suppose this matrix is given. They are asking about the multiplicity, right? Okay. So what you can do for this given matrix? First, you find out the eigenvalues. So if you see this lambda equal to 3 has two I mean it is repeating two times, so it has two multiplicity, right, which is algebraic multiplicity. So this is called algebraic multiplicity. So this is having two algebraic multiplicity, so either this. Okay, this is answer. So I mean D is not the correct answer, by the way. Right, now you need to check that how many linearly independent eigenvectors are there corresponding to lambda equal to 3. Okay, how many linearly independent eigenvectors are there? So for that, what you need to do, you just need to solve the equation which is ax equal to lambda x, right? I mean x, you need to find out how many x are there. So lambda is 3, so ax equal to 3x. So you just need to solve this system of equations, right? Okay, for the x. So in other words, you need to solve a minus lambda I or maybe 3i, okay, into x equal to 0. So basically you just need to solve ax equal to 0 or bx equal to 0, this kind of equations. So if you solve this, okay, a minus 3 lambda into x equal to 0, if you solve this, you will be getting this. So from here you can easily see, okay, or from here you can see it is, these are two linearly dependent, right? So since these are linearly dependent, you can see these are there will be multiple solutions. So you can say that, okay, lambda equal to 3 has this form, right? And there is only one linearly dependent. So basically there will be only one linearly dependent eigenvector will be there. Okay, so for lambda equal to 3, you are getting this kind of solutions, right? X to x, this kind of solutions you are getting. Okay, or from here directly you can observe that this is x, and then if you just add 2 into this, then you will be getting 0. Okay, from here you can directly observe. So k to k, you can say k to k. Okay, for lambda equal to 3, the eigenvectors are k to k. So there is only one linearly dependent eigenvector, right? So what is the correct answer? Only one. So I think A is the correct answer. Is this okay to everyone? Yes is saying using rank also we can say. How you can use rank? Can you tell me? How you can use rank? I think we cannot use rank here. Okay, we have to solve the question. So we cannot use rank, I think. Or you can tell me the whole method, then I will tell you. Otherwise, rank and eigenvalues are not related. I mean, rank and lambda equal to 0. Okay, rank and lambda equal to 0 eigenvalues are related. Then you can only say that if lambda equal to 0 is the eigenvalue, then rank is less than n. Okay, this is the only relation that is possible. Other than that, these are not directly related, I think. Okay, or you can tell me that what is the overall thing that you're talking about. Then I will tell you whether that particular thought process is correct or wrong. Okay. Now let's just solve this question. This question has been easy only, and this was 2 mark question, but yeah, this was easy question only. Can you tell me what was your answer for this question? What was your answer? So here they are just using a simple pointer thing, right? Okay. So let's just solve this question. So in this question, what they are saying, that P is pointing to A3, okay, address of A3 minus 2. So which means P is pointing to, this is A0, A1, A2, A3, right? A3 address of A3 minus 2. So this is A3, then minus 0, minus 1, minus 2. So basically P is pointing to, finally P is pointing to 1 only. Okay. So initially P is pointing here. Is this fine to everyone? Okay. This is the very first thing to understand here, that P is initially pointing to this particular thing, right? Okay. So once this is fine, then we can continue further. Okay. Now what they are saying, P plus equal to star P. Star P is actually 1. Now P will be pointing to this. Okay. You will be incrementing this. Okay. In the next step, P is pointing to this. Okay. So I think this is okay by mistake. This is 2 times I have taken the screenshot. So okay, that's fine. So I will just remove it. Okay. So now P is actually start pointing to this, right? Now they are saying okay, do you just print it? So the value that is getting printed is 4. Okay. So that's easy one. Okay. Algebraic multiplicity means that how many times that particular lambda is repeating. Okay. For example here this is repeating 2 times the power. Okay. This is called algebraic multiplicity. This power is called algebraic multiplicity. Geometric multiplicity means what is the number of linearly independent eigenvectors. So since this is only one, this is called geometric multiplicity. Okay. Now let's just solve this question. This question was a little bit on tougher side, I can say. Okay, little bit on tougher side. But yeah, that was again interesting question only. Once you see the solution, probably you will be able to convince that it is not that tough. Okay. I mean, it was a tougher question, tougher side question. But once you see the solution, you will be able to convince that okay, it was not that much tough. So let's just see this. So what they are saying in this question, they are saying that consider this code is there where x and y are unknown integers are initialized to 1. Okay. So here you notice one thing. Let me just zoom it out a little bit. Okay. So you notice one thing here, that we will be breaking out of the loop either I is less than y. I mean, this condition false. Okay, since I is always incrementing by 1, so I cannot, I see either after this, okay, after this loop, either I is greater than or equal to y, or I is basically not equal to x, right? I is not equal to x, or which means I is basically since I is only incrementing, so it will be basically sorry, I is equal to x. Okay, after this I equal x, then only it will break. So either this will help, or either this will happen or this will happen, right? After the loop, after the loop, only one of this thing will happen. Now more strongly I can say that instead of saying greater than or equal to y, I can say I will be y plus 1. Okay, why? Because I is incrementing only by 1. Okay, so this is true. I'm not saying this is false, but the stronger condition is this: I will be y plus 1. Okay, so sorry, I will be y, not y plus 1, because it is greater than or equal to y. Okay, so it will be y only. So basically what I'm saying, that this is true, but the stronger condition is this: I will be actually y. So after the loop end, I will be either x or y, right? So you will say after the loop end, at this moment, I will be either x or y. Okay, either this or this will happen. If the loop is getting breaked, okay, if the loop is getting break by this, then I will be x. If the loop is getting break by this, then I will be y, because I is always incrementing by 1. Is this fine to everyone? So basically I will be either y or I will be x. Now we just need to check, if I is y, then what is the j? Okay, if I is y, then what will happen to the j? If I is x, then what will happen to the j? Okay, that is the only thing we need to check. Is this understood? Right? So basically if I is y, then what will happen to j? If I is x, then what will happen to j? Okay, and then there is some other things that we will check. But if I just talk about A and D format, the A and D format is clear to everyone, right? Either I is x or I is y. Okay, so let's just check that what will happen. If I is x, I mean, let's suppose I is x or y, doesn't matter. You can take case 1. Let's suppose I is y. Okay, if I is y, then what will happen? Let's just check. So after the loop, you know that I will be either y or I will be x. See, if I is y, you are starting from 1, right? Then let's suppose y is 3. Then it will be running I equal to, for I equal to 1. Then I will happen 2. Then for 2, and then it will be basically running only 2 times. The moment I is 3, right? The moment I is 3, it will come out of the loop. So if y is 3, then it will running 2 times. So what I mean to say, that it will be running this loop. Okay, so I'm assuming the case 1, when out of the loop I is y. Okay, at this moment I is y, then it will be running how many times? Y minus 1 times. It will be running y minus 1 times. Okay, this loop will be running y minus 1 times. So when I is 1, so j will be j plus I, right? So j will be basically, you can say 1. It will be, I mean, it is starting from 0, then 1 will be added, then 2 will be added, then 3 will be added, and then till y minus 1 you will be adding. Till y minus 1 you will be adding, because you will be running whenever y is y minus 1. The moment y is y, I is y, the moment I is y, you will be saying that, okay, let me out of the loop. So 0 will be added, 1 will be added, 2 will be added, like this, right? Okay, so if you add this will be n into n minus 1 by 2, right? Sorry, n into n plus 1 by 2. So it will be y minus 1 into y minus 1 plus 1 by 2, which is nothing but y into y minus 1 by 2. So basically if I is y, then finally j is y into y minus 1 by 2, right? Similarly, if I is x, then it will be just running till x minus 1. Okay, you will be adding till x minus 1. In that case, it will be into, it will be j will be x into x minus 1 by 2. Okay, so A is the correct option. It is interesting question only. Are you trying to understand? So either this will happen or this will happen. Okay, in any of the case, you can just check. J will be just getting add up, right? Like this. So A is the correct option. But since it was MSQ question, so let's just see if what else are correct, right? Now just to check whether B or C, this is very easy, right? This is very easy to check whether V is correct or C is correct. If X is greater than Y, then what will happen to I? Okay, so if X is greater than Y, so it will not be breaked by X, it will be break by Y, right? It will break by Y. So I know that once this loop end, then I will be Y only, not Y minus 1. That is the only thing that I just told you, right? Okay, I mean, see, either this will happen or this will happen. Now, if this will happen when X is greater than Y, I mean, X is too far. Okay, this will happen when X is too far. This will happen then when X is less than Y. Okay, so basically they are saying, if this is happening, I mean, if X is greater than Y, then I is actually Y. We have just, I mean, we are keep on talking about the same thing, right? I is actually Y, not Y minus 1. So that is why B is also correct. Okay, that was nice question. I hope you understood. Yeah, you can take example of smaller numbers, that is fine. Okay, and then you can check it. But yes, this is this is the way to solve. If you are not getting, how to solve it like this, this is the one way to solve. Okay, you can definitely do it. But have you understood it now? Right, have you understood now the complete explanation? Okay, this is the complete analysis, I can say. So at this moment I is either Y or I is X, and in any of the case it will be adding up till X minus 1 or Y minus 1, right? Very easy question. See, after seeing the solution it was easy, but before that it might be looking tough. Okay, now let's see this question. This question was again a 2-mark question, and this was also easy question only. So what they are saying, when A is connected to host X, router X is connected to Y, and Y is connected to B. So I think I have the diagram. Okay, diagram is not there. So let me just try to solve this question. So they are saying this is A, this is X, this is Y, this is B, right? They are saying that this is, this is the network, right? And now AX, this particular link has the good MTU, which is 1500. This has 500 MTU. This has 492 MTU, right? Now, let's suppose there is some packet. Suppose host A is sending 1000 bytes of packet. Okay, suppose this is sending 1000 bytes. Okay, IP header size is 20 bytes. Okay, now what will happen, right? So it will definitely be received here. Now this 1000 is definitely containing IP header, right? So you will be dividing 980, and this is 20 bytes of IP header, and you will be dividing this 980 into a part such that it is lesser than 480. So basically 500 is including the IP header, so it should be lesser than 480. So one of this is 480, another one could be 400, right? Another one could be 400. So 400 and 480, and then plus 20 will be anyway there, 20 and 20. Is this fine to everyone? Now this is total 500. This is anyway lesser than 492. So, okay, is there any anything wrong, or this is fine? So this is 500, right? And we are sending, suppose host is sending 1000 bytes of data. Okay, total, I think this is 880 only, and there will be 100 also, right? There will be 100 also. Okay, so this is 480, and then 480, basically you have to have two 480, not 100. You have to have two 480, and remaining will be extra. So what is the remaining? If you have two 480, then the remaining will be, I think, 40, right? 40 will be separate. Is this fine to everyone? Yes, there will be 3 packets. Okay. Let me know. Is this fine? Now, now let's just continue with this question. Now, what they are saying that currently there are 3 packets. Now, suppose you want to deliver it to B, then what will happen? Okay, so this 40 packet will anyway will get passed, but these are the 500, and this is just 492, and 492 minus basically 20. This is just 472. It can only carry 472. So this is individual packet, right? This will be broken into 2. So you will say this is broken into 2. Right, this will also be broken into 2, and this 40 is as it is, right? This is 40, there will be 2 packets for this, there will be 2 packets for this. So 5 packets will be receiving to B, and then 3 packets over XY. Is this okay to everyone? Let me know. Okay, great. Now let's just move to this question. What they're saying, imagine a world where IP addresses are 4-bit long, okay, not 32. Now you just have 4-bit long IP addresses. Suppose a router uses longest prefix, right? Suppose longest prefix match. So you know longest prefix match rule, right? And you have this as a forwarding table. Now they are saying, suppose that a packet with the address 1001 is forwarded to interface C. Okay. So by the way, what could be the possible values of X? Can you first tell me? Possible values of X. If you are sending 1001 to C, it means the X could be 1001 itself, or it could be 100 also, right? It could be 100 also. I mean, these are the 2 possible values of X, right? These are the 2 possible values of X. Okay. But the question is not asking the possible values of X. They are saying how many possible addresses will be forwarded to the interface B. Okay. So they are asking about how many addresses will be forwarded to B. So basically, basically, is this question about B or D? Is this a correctly printed or there is some misprinting? Can you tell me? In the exam, okay. I think that is correct, right? In the exam also I asked for B. The confusion was because initially I think I was thinking to ask for D, but that's fine. Okay. So let's just check this. See, what will happen if you are starting from 1. See, if you are starting from 1, then it might go to B. It might go to B. But if it is 10, right? If it is 10, then anyway everything is blocked, right? I mean, it will not go to B. So if it is 11, if it is 11, then these are the 4 packets which will go to B, right? If it is 11, anything that is starting from 11, it will go to B for sure, right? There is no other way, because here for the C it is either 100 or 1001, right? If it is starting from 11, it will go to this. But what if it start from 10? If it start from 10, then definitely it will go to A only, right? If it will go to A only. So if it is starting from 11, then only it will go to B. So I think 4 packets, right? 4 packets will be going to B. Okay, if it's starting from 11. Now, is this fine to everyone, by the way? First tell me. Now I will tell you another thing. Suppose they ask you for D. Okay. Suppose they ask you for D. Okay. Suppose they say that what are the total possible that will go to D, right? So in this question, let's suppose they say that, okay, what are the total possible that will go to D? So by the way, what are the possible values of X? It was 100. I have just told you it was 1001. Okay. Now, what will be the possible values? Okay. See, if something is starting from 1 1, it will anyway go to B. Something is from 1 0, then anyway go to A or C, right? I think, okay. So in this case, D will not be even needed, right? D will not be even needed, right? I think for all the addresses, either if it is starting from, yeah, if it is starting from 0, then it will go to D. Okay. If it is starting from 0, then it will go to D, right? So if it is starting from 1, then either this or these things will take over. But it is starting from 0, then it will go to, right? So I think 2 power 3, right? 2 power 3 addresses. 8 addresses will go to D. Okay. 8 addresses. Is this fine to everyone? Okay. Yes, I think might be possible. This question, I think mock test mein I put this type of not the same question, but yes, the same type of question I put it. Maybe in the mock test or maybe in the weekly quiz. I don't exactly remember, but yes, not the same question because this question is new. This question was new for sure. Okay. Yes, I think it was in weekly quiz. In weekly quiz, same type of questions, not the same question actually. This question is definitely new question. Okay, but the same type of question I might have put in weekly quiz. This was interesting question, right? Easy question only, but yeah, interesting question. Okay. Now let's just solve this question. So in this question, they are saying a message of size 10,000 bits, not bytes. Okay. I mean, we have written it, otherwise it's not required to write it. Okay. They are saying not bytes is sent from A to destination B, passing through two routers R1 and R2. All three links on the path have the delay of 20 millisecond. Propagation delay is given. A has the transmission rate and B has some other transmission rates. Okay. So the transmission rates are different. So that is why the transmission time will be different. Okay, which is fine. Find the total sum in the second transmission. Okay, so they're asking what will the total time that will taken if that file is broken into 10 packets. Okay, the 10,000 bits file broken into 10 packets. Then what is the total time that will be taken? So let's just solve this question. That was easy question only. So if you find out the transmission times, which is length upon bandwidth. Okay, since here the bandwidth is 1000, right? Here the bandwidth is 1000 or something. Yeah, 1000, and the length is basically for each of the packet length is 1000 bits. Okay, and there are 10 packets, 10 such packets, right? So basically 1000 is the length packet, 1000 bits, right? Okay, and bandwidth at A is 100. Okay, so bandwidth at A is 100. So basically it will be length upon bandwidth 10 seconds. So it will be 10 seconds and rest is 1 seconds only. Okay, because 1000 upon 1000. So basically transmission time you can say here will be more because bandwidth is just here, bandwidth is actually less, 100 seconds only, right? Here is more. And propagation time is given to given for the links. They are saying it is 20 milliseconds for each of the link, right? Now suppose you want to send 10 packets. Okay, so I told many times. So in these type of questions, what you need to do? Suppose you want to send 10 packets, you just have transmission time of all the packets, and then for example transmission time of 10 packets, and then just focus on the last packet. So transmission time of all the packets and time for reaching, then focus on the last packet. Is this method okay to everyone? Okay, I only told this method. Okay, I don't know I should use that word or not. Okay, maybe I can use that word. Discovered. Okay, discover this method. I discovered this method. Okay. For the PYQs also, I have already answered these type of questions using this method, that you have the propagation time for all. Okay, and then sorry, transmission time for all, and then just focus on the last packet, right? Then the last packet will go. This will take this time, and then how much will get transmitted, then we'll take this time, then we'll get transmitted, then we'll take this time, like this, right? So for any link it will any link it will TP plus TT, right? TP plus TT for the first link, second link TP plus TT, for the third link it is just TP, right? So that is why you can have 10 packets transmission time, and if you focus on the last, then it will be the answer. Okay. So basically, for the last packet, the transmission time, you can either have the transmission time on the left node or right node. So suppose I'm having the left node. So transmission time, you already taken care, because in this 10, and then you just need to take care of the propagation time. Then transmission time plus propagation time, transmission time plus propagation time. So for any of the link, the transmission time you can add here. I mean, start node or the end node. So you can use any convention. So let's suppose I'm having the transmission time at the start node. So transmission time, I mean, just for the sake of calculation, I'm telling. Otherwise, it is better to have the transmission time at the start only. Okay. So if you solve it, 102.0.06 is the correct answer here. Okay. Is this fine to everyone? Let me know. Okay. Now let's just move to the next question. Yes, this was very nice question. How many of you were able to solve this question? This was a nice question. Okay. How many of you were able to solve this question? See, generally people think that safe sequence means that we will only allow this sequence. No. Safe sequence means, first of all, there is only one safe sequence. Okay, that is fine. By the way, safe sequence means that if you have the maximum needs of P1, I mean, in this order, you can definitely satisfy even the maximum needs. Okay, you can definitely satisfy the maximum need of P1 and then maximum future need of P2. Okay, so safe sequence and maximum need, are very much correlated. Okay, so safe sequence means in this order we can satisfy the maximum need. Okay, in this order we can satisfy maximum need. Okay, maximum need. In this order we can satisfy maximum need. Now in the question, let's suppose it says, or maybe like there are like if you have seen operating system lectures, or maybe you have studied from anywhere else, I don't know, but you might have noticed that what we do, we say that okay, this is the safe sequence, but can we satisfy any request from P2? Yes, we need to check if we satisfy the request from P2. After satisfying the request from P2, are we getting another safe sequence or not? This is the current safe sequence, which is true. But can we satisfy the request from P2 instead of satisfying the request from P1? That is okay. We can do it. Okay. At that moment, let's suppose P2 is asking, can we do it? We need to check it. If we do it, then the resulting safe sequence is safe sequence or not. Okay. Whatever. I mean, are we getting any safe sequence or not? So basically, if P2 is the first process to the request for some resources, then P2 will always have to wait. No, we can do it, right? We can basically satisfy the request of P2, and then we need to check the resulting we have any safe sequence or not. If we have safe sequence, we can definitely do it. Okay. So always have to wait? No, that is false. Is this okay to everyone? Let me know. Is this fine? So that is wrong. P1 request will always be satisfied without even checking. See, that is the beauty about the safe sequence. See, I know that P1 maximum I can satisfy. In this order, I can definitely satisfy. And P2 maximum I can satisfy. And P3 maximum I can satisfy, right? This is what the safe sequence mean. So P1 maximum definitely I can satisfy. I don't need to check anything. I've already checked the things, right? So P1 maximum I can satisfy. And I will always be getting safe sequence after that. Right? And the safe sequence will be this. Because P1 is out of the picture. Okay, if it is not asking for maximum, that is fine. But yes, and the resulting safe sequence, I can tell you, resulting safe sequence will be the same. Okay, this will be the same resulting safe sequence. Why? Because earlier, let's suppose P1 is asking for 5 resources. Now, I mean, this is the, let's suppose, maximum need. Now let's suppose I say that okay, now the maximum future need, let's suppose I 2 already are satisfied, maximum future need is just 3. Then also this is a safe sequence, right? So basically P1, for the P1 I can always satisfy without any checking, because P1 even maximum can be satisfied. So that's why B is the correct answer. Okay, since it is MSQ, let's just check maybe other than B are also correct. Process request will always have to satisfy in some order, in the same order as the safe sequence, and we cannot satisfy any out of order process request. No, we can satisfy. After satisfying, we need to check whether the resulting sequence, I mean, if there is any sequence which is safe or not. Okay, after satisfying, we need to check. Understood? Okay. We can never satisfy any request from P1, Pn. No, we can do it, right? We can do it. We can satisfy. So we can never, because of never, this is false, right? We can actually satisfy, because it's not like that we cannot satisfy from Pn, P2 like this. No, we can actually satisfy, right? Yes, it was very conceptual question for sure. Okay. Now let's move to the next question. Yeah, this was related to OS. Let's just solve this question. I think 2-3 questions are remaining. Okay. So let's just solve this question. What they are saying, suppose there is a machine with 32-bit addresses and 2 label page. I think diagram I have. Okay, diagram I have. So they are saying, let's use the same diagram. They are saying that 10 bits of the addresses in the first label page table and 10 bit in the next label. Suppose the each entry in the page table is 32 bits. Okay. Okay, so page table entry is given to me, which is 32 bits. Page table entry. And page size is also given, 32 bits. 64 MB is what? How much minimum space is occupied in the memory by the page tables for the process that has 64 MB of actual virtual address space. Okay, from that I can find out the page offset. So if it is 64 MB virtual address space, which means 2 power 6 into 2 power 20, which is 26. So for the from the 20 bytes, right? So from the 26 bytes, this is a total virtual address space. 2 power 26. Just a second. Okay, virtual address space is given to me, 32-bit address space. Okay, great. So from the virtual address space, actually we can find out the page offset. Okay, and 64 MB is something that it is using. Okay, I mean 2 power 32 is total virtual address space. Out of that, they are using 2 power 26 only. Okay, bytes. So that's what they are saying, right? 64 MB of actual virtual address space is allocated. Okay, so only 64 MB, 2 power 6 into 2 power 20. Okay, so 2 power 26 bytes are actually allocated. Okay, out of 2 power 22, 2 power 32, right? So let me write the process size also. Process size. Is this question clear to everyone, that what they're asking? Let me know. Now what they're asking is basically they're asking you that what should be the page table space that page table should be taking, right? So how much space page tables should be taking? Okay, so how many of you were able to solve this question, by the way? This was not a hard question, to be honest. This was easy question only. See, one thing is for sure, that first label will be taking the one page table, right? It will be taking one page table. Right? It will, I mean, it will be taking one page basically, right? It will be taking one page. Is this okay to everyone? Okay. So these are basically 32 bits, or you can say, if you like to write in the bytes, then you can also write in the bytes, which is how many bytes? 32 bits will be 4 bytes, right? So it will be 4 bytes. So how much space this outermost will be taking? There will be 2 power 10 entries. Okay, there will be anyway one page table, or maybe you can write like this. There will be 2 power 10 entries, right? Because of this 10 bits, and each entry will take 4 bytes. So 2 power 12 bytes. Okay, 2 power 12 bytes, or anyway one page. Okay, one page basically 2 power 12 bytes only, right? So this is okay to everyone, right? This will be taking 2 power 12 bytes. Let me know if that is fine. Now we need to basically check that how much total space other page tables will be taking. So let's just do it step by step. So see here that we are having 64 MB total space, right, of the process. From the total space, can you tell me number of pages that process will be taking? Number of pages, it will be 2 power 6 into 2 power 20. This is total space divided by one page size, which is 2 power 12, right? 2 power 12. So how many space it will be taking? 2 power 6 2 power 6 into 2 power 14, right? 2 power 6 into 2 power 14, or in other words you can say 2 power 22. Just a second, this will be 2 power 14, basically 2 power 14. Okay, this is 2 power 8, and 8 into 6, 2 power 14. So 2 power 14 pages it will be taking, right? So process will take these many pages. Is this fine to everyone? So 2 power 14 pages it will be taking. It means that how many entries it will be taking here? 2 power 14 entries. So 2 power 14 entries it will be taking, right? So here it will be taking 2 power 14 entries at this level, because here you have to have 2 power 14 pages. So here it will be taking 2 power 14 entries. So for 2 power 14 entries, since one page is how many size? Okay, one page is 2 power 12 bytes, or in other words, how many entries it will be taking? One page, you can say 2 power 10 entries, right? So at this level, how many page tables will be required? Are you getting my point? So one page can take one page table can take 2 power 10 entries at this level, right? And we need how many entries? We need 2 power 14 entries. So basically you can say 2 power 14 divided by 2 power 10. So 2 power 14 are the total number of entries we need, and 2 power 10 is number of the entries which will be taken by this, right? Which the one of this page table can accommodate. So 2 power 10. So 2 power 4 pages here will be taken. So 2 power 4, right? So here I need 2 power 4 pages, which is 16 pages. Okay. And here I need just one page. So total 17 pages. Is this fine to everyone? And each page, basically, you can say is of how many bytes? 4 bytes. Sorry, 4 kilobytes, 2 power 12, right? 2 power 12, which is 4 kilobytes. So 17 into 4 kb. Okay, 17 into 4 kb, which is 68 kb, is the correct answer. Should I explain this again? Let me know. See, what I'm trying to say, that process is taking 64 MB, right? So it means it is taking 2 power 6 into 2 power 20, which is 2 power 26 bytes, right? Which is same as saying, if we divide by 2 power 12, which is same as saying 2 power 14 pages, which means 2 power 14 entries I need here. 2 power 14 entries I need here, which is same as saying one page table can take 2 power 10 entries. So 2 power 14 divided by 2 power 10, which is same as saying 2 power 4 pages here I need, right? And here I need just one page, right? So total 17 pages I need, and each page is having basically 4 kb size. Okay, so 68, right? 68 kb. Is this fine to everyone? Yes. So you can solve in this way or in any other way. Okay. So I hope that is fine. Now let's just move to the next question. Okay. So in this question, basically, you just need to observe that if you factor out this 360, okay, if you factor out this 360, which is 2 power 3 into 2 power, sorry, 3 power 2 into 5 power 1, right? Which is basically 8 into 9 into 5. Okay. If you do 8 into 9 into 5, can you quickly check? Is this coming out to be like this? Yes, right? So basically, you just need to factor out this 360. So you just need to make sure that x is not equal to 360 means that you just need to make sure that out of this x should be 360. Out of all of the computation, you should be setting the values such that x should be 360. Okay, x should be 360 out of all of this loop, because you want to basically make this condition false. Okay, you want to make this condition false. So that is why x should be 360. I mean, out of all of this, x should be 360. So which means you should be running, since it is multiplying by 2, you should be running this 3 times, this 3 times, this 2 times, and this 1 time, because this is multiplying by 3, this is multiplying by 5. Okay, like this, right? So basically 3 times, 2 times, and 1 time. And this is just, something which is protecting. So this is just a kind of binary semaphore. Okay, it is just for the protection. Understood? Okay. Now let's just move to the next question. So here in this question, it is also easy question. Here in this question, they are just asking you if you can tell that how many reductions will be needed. So this question can be solved using the RMD. You don't have to follow. You don't have to basically make the parsing table and all, right? You can just follow the RMD, and then you can just do this question. Okay. So for example, if you just have the RMD, because bottom up parser works in the RMD way. Okay, and it is already given that grammar is LR1. So how many reductions are needed? Shift obviously with 3. Okay, these are the 3 shifts. And how many reduction? 1, 2, 3, and 4. So 4 reductions and 3 shift. So what is the correct answer? 3 shift and 4 reductions, right? C is the correct answer. Okay. Yeah. So that is all about this AIMT discussion. I hope you like the discussion. Let me know if there is any doubt, and also let me know that how you're liking the AIMTs and particularly the discussions, right? How you're liking the AIMTs and discussions. Okay. Let us know in comment, because each of your comment just motivate us to put more and more efforts. So let us know in the comments that how you're liking it. Okay. So thank you everyone for watching, and hopefully you will be doing good in gate. Okay, not just good, you will be doing great. Just have some positive mindset for now. Okay, don't spread negativity. Don't watch or don't read Telegram or WhatsApp messages when people are saying they are feeling demotivated or like that. Okay, maybe some people are just doing it intentionally. That is why I'm saying. Okay, so just be with your family, eat healthy, drink lot of water, and just think positively. Okay, for this remaining 3-4 days. Okay, thank you everyone. Just let me know in the comments if you're liking everything. Okay, how you're liking